why is the limit of sine of x over x is 1 as x approaches 0? Is it because L'Hopital's rule, once we see the 0 over 0 type, differentiate top and bottom, cosine x over 1, approaching 1 as x approaches 0. Okay. Logically, it's wrong. Cyclic proof, because how do we know that the derivative sine x is cosine x? How do we know that? We know that, for example, sine x plus h will let h approach 0 minus sine of x, according to the very definition of derivative over h. Right? We will let h approach. So that means we just have to work out the, first of all, angle sum, sine x cosine h plus cosine x sine h minus sine of x over h. Then we can just break them apart. First, I'm going to use this part over h. Cosine x sine h over h. Then I'm going to use that part over h. Sine x cosine h minus sine x factored out. Cosine h minus 1. Right? First of all, assuming we know that the limit of this is 1. Right? So sine h over h approaching 1 as h approaches 0. Right? So this whole thing approaches, right, treating x as a fixed constant. Right? So it's approaching cosine x. Right? So this part, how about this part? So first of all, cosine h minus 1 is equal to double angle formula. 1 minus twice of sine squared, half of h, then minus 1. Right? Minus 1, 1, cancel it out. I have this. Right? So in the end, this part actually equals sine x times minus 2 times sine squared half h. This is what I have on in here. Cosine h minus 1 is this. Then over h. Right. Then first of all, cosine, that is equal to sine x times negative 2 times sine squared half h. Right? So I just need to have half of h squared. Right? Just to be aligned with this angle, half h square. Then I have h indeed. How do I maybe multiply by h and 4, right? 4 and 4 cancels, and h squared, h, yeah. Exactly, still h, so just need to work out this. But since sine, so this limit, right? We have this, right? So this is the square of sine half h over half h, or still approaching 1. And this, what I have, the constant, right? Multiplied by h on both top and bottom. So this h is gone. I have this h. Right? So minus this, don't worry about constant. Right? All I know is that h is on the top now. So x is a fixed constant. Right? This is constant, don't worry about that. H approaches 0. Right? Constant times something approaching 0, of course approaching 0. Right? So 0 times 1, still the whole thing approaching 0. Right? So don't worry about that. Right? This is gone. all I need is this. All I have is this, cosine x, right? So that's how we know that the derivative of sine x is cosine x, because we know that the limit of sine x over x is 1. Right? So the logic works this way. So now coming back to the question, how do we really know that this limit is 1? Logically. Right? So here is a relatively more rigorous proof. First, I'm going to draw a partial over a circle, unit circle, restricting alpha between 0 and half pi. Since we're talking about limits, therefore I need pi, need alpha to be small enough. Then I'm going to draw this line segment. This is the middle point. Then I'm going to have a radius of just 1. And this is my radius. Same radius. And I'm going to draw the arc. Right, this arc. Then we'll just say point A, point B, point O, angle alpha between 0 and half pi. I'm going to divide the line segment AB into n equal parts. So this perhaps call it this A naught. So this part, and perhaps this part, right? Equal parts. Then I'm going to draw this point A1, and the projection of A1 onto this line segment is A1 prime, and also this point A2 projection is A2 prime. Right? Equal parts, right? And equal parts, so that my line segment, right, this is the line segment, right, A0, A1, line segment, another line segment, line segment. Right, so in the end, my purpose is to show that the length of the sum of these line segments is bigger than line segment AB. Right. So first of all, the angle denoted as angle naught, alpha naught, angle alpha naught is the angle between the line segment of A0, A1 and line segment AB. So likewise, alpha 1 is the angle between the line segment A1, A2. So A1, A2 and line segment AB. So on and so forth. So generally speaking, the alpha j is the angle between AJ plus 1 and AB. So then I'm going to show that every alpha is less than this alpha. Right? First of all, if I draw a tangent line at this point, maybe this point C. Right? So this is tangent line, therefore the angle CAO is exactly 90 degrees. Right? Then which means the sum of angle CAB and angle BAO is equal to this angle, half pi. Right? And I also know that since these two angles are the same, therefore this angle has to be 90 degrees. Right? So this angle plus this angle has to equal to this angle 90 degrees. Right? So alpha plus angle BAO also 90 degrees, right? So both half pi, both they have angle BAO. And then I can easily tell which angle is big. So which angle is bigger? Angle CAB bigger or angle alpha naught? Which one is bigger? I say angle alpha naught is smaller than angle CAB. Why is that? It's obvious from the graph, right? Because the angle alpha naught is the angle between the line segment A naught A1 and AB. And A naught A1 is a secant line, right? Secant line within this arc. And AC is a tangent line, right? So this is obvious, right? This inequality is obvious. So therefore, alpha naught is smaller than angle CAB, right? So therefore, first of all, from this equation, right, half pi, BAO, BAO, I immediately see that alpha has to equal to angle CAB. Right? Then alpha naught is smaller than angle CAB. Therefore, alpha naught is smaller than alpha. How about alpha 1? Alpha 1 is the angle between this line segment and AB, right? So obviously, alpha 1 is even smaller than alpha naught. And alpha 2 is even smaller than alpha 1. Of course, every alpha is smaller than the first alpha, alpha naught, right? So, right? In general, alpha j is smaller than alpha naught. Right? J from 1 to all the way to n, right? Smaller than or equal to alpha naught. Alpha naught smaller than alpha. Right? So every alpha j is smaller than alpha. So we're fine. Now my job is to, first of all, first line segment, this line segment is smaller than this line segment. This is obvious, right? And in general, every line segment down here is smaller than this line segment, right? Because this line segment is the projection of the line segment above. So this is obvious. So in general, AJ prime, AJ plus 1 prime, this line segment length is smaller than the line segment above. Right? That is AJ plus 1. Right? But how do we rewrite this? This can be rewritten into cosine alpha j under AJ prime, AJ plus 1 prime line segment, right? This just trigonometry, right? So this line segment can be, so this line segment is this line segment times cosine, right? If we want to describe this line segment, we just have to use this line segment and divide it by cosine, right? Divided by cosine. Right? Then we can just add them all up. j goes from 0 to n. Right? This line, so this line segment, this line, so line segment AB. Right? Its length smaller than this line segment plus this line segment plus this line segment. It just use this notation. A0, A1, all the way to AN. This is a notation. Right? Right. So again, this part, this sigma sum, right? J. How about this part? This part also sigma. Sigma j goes from 0 to n. Right? But since so let me just first sigma j goes from 0 to n. Cosine alpha j aj prime aj plus 1 prime. But then because like I showed, every alpha j is smaller than alpha. So what does that mean? So that tells us if we apply cosine alpha j is bigger. Cosine is a decreasing function over 0 to half pi, right? So it's bigger than cosine pi, alpha. Right? So if we replace every cosine alpha j with cosine alpha, then the bottom will become smaller, but the whole fraction will become bigger because everything is positive. So I've loosened the inequality, make it bigger, right? So this is smaller than cosine alpha, right? Taken out of the sum. I still have sum of this, right? But the sum of these is just again AB. Where is it? Just AB. Right. But what is AB? What is the length of AB? Right, that's nothing but half of AB is equal to this hypotenuse times sine this angle. Right? The unit circle hypotenuse 1 times sine alpha equal to this length. So I have twice of that. Right, so in fact I have twice of sine alpha representing AB. Right? That is less than if I just let n approach infinity. Right? I let n approach infinity. Maybe I let n equal to 2 to the power k. K approach infinity. Right? So this is the sum of this segment, this segment, this segment, this segment. So as n approaching infinity, well, this limit will become the arc length. Right? The arc length is first this alpha, right? So half of the arc length is alpha. Right? I have twice of alpha is the arc length. Right? So twice of alpha. And the right-hand side stays at right-hand side. Right? Is less than AB. AB, like I said, twice of sine alpha over cosine alpha. And this is the inequality. So which means I have sine alpha is less than alpha is less than tangent alpha. And this is the inequality I have. If I divide, because remember I need to work out this limit, and then I just have to divide both sides by alpha. Right? What do I have? Sine alpha over alpha. Alpha is positive, right? Less than 1. Right? So tangent, so let me just rewrite tangent alpha into just sine alpha, cosine alpha. Right? It'll be more useful. Right? So divide this alpha down here. Multiply this cosine over there. So bigger than cosine. Right, bigger than cosine. How about minus sine alpha over alpha? Right, change the inequality, change direction. Smaller than, bigger than that, smaller than, minus cosine alpha, bigger than minus 1. If I add 1 on both sides, so 1 minus 1 smaller than 1 minus sine alpha over alpha. And less than 1 minus cosine alpha. I have this. So left hand side 0. Right hand side is 1 minus cosine alpha. Maybe it's approaching 0. Probably gonna approach 0. Because 1 minus cosine alpha is equal to double angle formula. Cosine alpha is equal to 1 minus twice of sine squared half of alpha. Right, alpha equal to twice of sine squared half of alpha. Right. So, like I showed, twice sine alpha is less than alpha. I've just showed. So sine alpha must be less than 2 times half alpha quantity square. Right? 4 under alpha square. Right? So constant times alpha square. As alpha approaches 0, this side approaches 0. Right? So 1 minus cosine alpha really approaches 0 as alpha approaches 0. Squeeze theorem. The middle also approaches 0. Which means sine alpha over alpha approaches 1 as alpha approaches 0.